Hey folks, we're looking at this idea of quantiles and thus percentiles for normal distributions, and we're looking at how you work with them basically. Just explain what these things are. Quantiles and percentiles are pretty similar things, and they give us information about a distribution, and in this video we're still looking at normal distributions. And quantiles refer to a place where to the value below where there's a specified probability. Okay, if we're talking about where a random variable like x will occur, it gives us that point. For example, you've seen perhaps things like this here. Okay, so probability z is less than some value of a is 0.7. We call that the 0.7 quantile. So it refers to that probability or the area under a curve. So the 0.7 quantile corresponds to where we put that line such that we get 0.7 probability of a random value falling below that on a normal distribution. Therefore percentile is pretty much a very similar idea. You see, we would call this task here determine the 70th percentile for this normal distribution. So a 0.7 quantile means a 70th percentile. See, so they're very similar, and they're used interchangeably, I suppose. Two quick examples we've got. For the normally distributed variable x, we're given a value here. The 0.15 quantile is limited by 1.9227. Now that value is quite small, okay? So that means it's going to be well left of the mean when we do our little sketch. Okay, so you can see the corresponding values there. And by the way, we have to find the standard deviation, and the mean is 2.7. They threw that in for us. So we've got, can you see there? We've got the mean is 2.7, and that's that red line there. I've already put it in, save some time, and 0.15 zone is there. And the 1.9227 is that other line there. So the 0.15 quantile is the region below that shaded. Okay, so we can set up our expression like this here, and we know how to deal with that and with our calculator, because you see we have to find the standard deviation. So a very convenient formula linking these two together is our old friend z equals x minus mu over sigma. And we know all of these things. Well, we can find the z with the aid of our graphics calculator. Thus the only unknown will be sigma, the standard deviation, which is what we're trying to find. So we set up our expression, as I said, and then we need to find, with the aid of our graphics calculator, a z-score such that we have this quantile, the 0.15 quantile, the area under a curve. Using inverse normal on our graphics calculator, that will give us a z-score of negative 1.0364. And then we can use the formula that I mentioned just before, this one here, and negative 1.0364 equals, now x, the score was here, 1.9227 minus mu, which was 2.7 over the standard deviation, which is what we're trying to find. And we do a bit of rearranging, and sigma comes out as 0.75. Okay, the final example, we are looking at the final part of the video. We have x is a normally distributed variable, so that the 63rd percentile, so that means quantile of 0.63, like from the previous one, and its value is limited by limited at 15.896. We're given the standard deviation. We've got to find the mean this time. Okay, it's going to have some similarities to the last one, but you know, we got an area of 0.63 here in this purple zone, the entire purple zone there. Okay, and those people with obsessive compulsive disorder may hate the fact that I didn't bother shading that in properly, and we now write down our expression, which I've pre-populated there. So for the x score to be less than 0.896, as you can see there, that is equal to 0.63, and then we can use our graphics calculator to come up with an equivalent z-score there. Okay, big Z, little z. What is that? And we can use our calculator to find that, and that will give us a little z of 0.3319. And using our formula again, so remember it was z equals x minus mu over sigma, and 0.3319 equals 15.896, yes it was. Okay, now remember we're given the standard deviation and it is 2.7, but we've got to find mu. So mu, the mean, we've got to find. We rearrange that and that gives us our final answer. Which is 15. So the mean is 15.